So, good morning, everyone. And today's session is all about market bucket association and analysis on this. So, this algorithm mainly talks about when there is an association between the two. So, let me start with some simple examples and give you some context about this algorithm. So, what happens is it depends upon your buying behavior, or if there is an association between the two uh, events. Let's say when you go to a supermarket and you have bought some potatoes, and with that you have bought some onions. So it is also quite likely that you might buy some bread as well. So there comes association rules into picture, because based on the similar trend, it is observed that if you are buying these items, you are also likely to buy another item. Let me take one more example to explain. So let us say if you're buying coffee beans from a market, and at the same time you're buying sugar, it is also quite likely that you will buy milk as well, because to make coffee, these are the key ingredients that you require. So this is a simple example, and how we do it and how we deal with it, we'll see in further slides. So this is mainly about predicting of customer behavior. So even in a Amazon app, as you could have seen, uh, if I buy a certain product, or if I add to cart certain product, then it is also then what Amazon does is they start suggesting me some other products which is related to my previous bought product. So based on this, what happens is, based on the analysis of previous customers, that how they have behaved, and what a person is quite likely to buy, they keep suggesting or recommending new products to a customer. So by and large, this is a moreover a picture of association rules. And also this is quite required as the scenarios are changing. So entire uh, market is shifting to online, and there you need to capitalize on this methods that you have. So once you start targeting your customers, you will have an upper hand, compared to your competitors, because you can able to target or segment your customer well, and you know what your customers behavior, and you can uh, suggest or recommend accordingly. So even in YouTube, you could have seen that if I browse a particular video and if I go through it, then there are certain recommendation on the right hand side that I get. So this was a video that I was watching in the early morning today, and I got some recommendation on the right hand side. So this is mainly because, see, there is an association between the video that I'm watching and the recommendation that I'm getting. So it is. I was watching this video on Weasley. So this is based on the Harry Potter theme, where it talks about origin of Weasley families, and in the same time as Ronald Weasley was one of the friend of Harry Potter, it gives me suggestion of ho- people who are related to Harry Potter in a similar way. So Luna Lovegood was also a friend of Harry Potter. Neville Longbottom was also a friend. Murderers are kind of, they were guardians of Harry Potter. Actually, they were friends of James Potter. So in a way, it starts suggesting me people who are related to Harry Potter or some. And in the last suggestion, if you can see, it talks about founders of Hogwarts. So it goes back to 1,000 years earlier. So one which is more closely related, and after that one which is quite far related. So this kind of recommendation that I keep on getting upon what is most likely to be having targeted and what is least likely that a person would go for. So the examples that I have explained a bit earlier, that about coffee, that if I'm buying a coffee and at the same time I'm buying some sugar, then it is also likely that I will buy milk. And also here one more example has been mentioned, that for example I'm buying some products for dental care, so toothbrush, paste, mouthwash and other dental products come together, and also they, on basis of this my past behavior, they will try to target me even further products that I'm quite likely to buy. So what is this rule all about? So in data mining association rule, learning is a popular and well researched method for discovering interesting relation between variables in large data sets. So this is a very important point because it comes into picture in very large data sets only. Now the problem with the association rule is you cannot try it on a small data set because you don't have much data to work on. Only you have, when you have built up a large data set and you have a quite large number of data to make your analysis and to understand that what has been my customer behavior, only then you can get to a conclusion. Otherwise, association rule doesn't work very well. So this point is very important to understand that it works well on large data set. And even when you look at the case studies that I will be covering today, I've taken some large data sets there. It is intended to identify strong rules discovered in the databases using different measures of interestingness. The rule found in the sales data of the supermarket would indicate if a customer buys onion and potato together, he or she is likely to buy hamburger meat. Such information can be used as a basis of decision about marketing activities such as promotional pricing or product placement. So as I explained earlier, so this is a main common example or application of association rule. So someone was asking in a question, or is it good till here? Okay. So and one more thing that I want to mention, that this is an unsupervised technique, unlike the other technique, and this is one is an unsupervised. And I want to ask from you why it is an unsupervised technique. Why not supervised? Okay, so I think so. We will come to that. Uh, I will explain that why it is an unsupervised technique. So here are a few examples that association rules are implemented. So Amazon customers who are bought could have also bought this music recommendation. So like I showed you on YouTube. So once you play a music, at the same time it recommends you another music. Medical diagnosis as well, uncovering hidden patterns and generate tools for health science set to predict occurrence of disease such as diabetes. So if I have sort of these kinds of medical conditions, then on basis of that, uh, what could my what could be the consequences that I'm going to face? Then content optimization and so on. So there are some good features about association rules that we have. So if I have large number of data sets, association rules work quite well. It is, I think, an ideal scenario to work with that. But when it comes to small data set, then it is something that I won't be good to take or adopt. And also good thing that in layman's term, there are not so complicated terms in this algorithm. So it becomes quite easy to understand. We have only three major terms here: support, confidence, and lift. These are the only three major terms, and we only work on these three terms, basis of these three, filtering out on basis of these three, trimming and subsetting, funneling, all on the basis of these three parameters only. Uh, And there is a reason why I said that it is an unsupervised technique, because here you have to put the algorithm at a go. So once you have got the data set, you have made your association rules, and now start making the recommendation. So ideally, once the data set comes, you have a large repository of data sets, and after that, apply these association rules on them and start recommending. So this is how it works. One of the similar findings that we have is searching for interesting and frequent patterns in DNA protein sequence is study of genetic disease. So in DNA, you must know that there is a pattern kind of you know of protein molecules or elements that are present. So even for that, if so and so is the sequence, then what would be the next sequence? And that could also be determined. Finding patterns that occur in a combination of fraudulent transaction or claims, and identifying patterns of behavior that signal increased likelihood of customer loss. So now talking about the main statistical term that we have in association rule. So here, as I said earlier, here we have only three major terms that you need to learn and understand: that support, confidence, and lift. Now, what is support? So, support is mainly actually the proportion, or you can say the probability, that out of entire number of transaction, how likely is my transaction to occur. So, let's say there are n numbers of transaction, and out of that, my transaction. Suppose my transaction was that I went to the store and bought a CD of a movie. So, buying CD of that particular movie, how many times that has occurred compared to the entire number of transactions that I have. So that is my support. Confidence is now, let's say here comes the association with the other item. Now till now I was dealing with only my product or the product that I have bought. Now comes into picture the other product. So let's say here what happens, support of my product and another product. Suppose I have bought the CD of let's say Bahubali 1, and the next CD that I bought is for Bahubali 2. So given the condition, my confidence, actually this means support for Bahubali 1 and Bahubali 2, both of them occurring together, divided by support for Bahubali 1. So all it means that given that you have bought Bahubali 1, what is the probability or the chances that you will go for Bahubali 2? So this mainly deals with confidence. And here I have finally left. So support for Bahubali 1 and 2 united, both of them you have bought together, divided by support for Bahubali 1 independently into support of Bahubali 2 independently. So this is how lift works. So these are the three major terms that I have. So one more thing, if you all remember, we did a probability term. So naive Bayes has a bit different. So as I explained in the previous classes, naive Bayes works on conditional probability. So here also we have a bit of conditioning, that is true, but terms are a bit different. Like you can see, so occurring of this event, given that this has happened, so this is also part of conditional probability, true, but a bit different algorithm, I would say. So in naive Bayes, if you remember, we didn't had so many numbers of parameters like we have here, like support, confidence, and lift. There was just conclude the conditional probability and find out which is more probable to happen. So let us take an example and try to understand that. So consider my X is Bahubali the beginning and Bahubali the conclusion. So I have here two movies. First of all, I have bought Bahubali the beginning, and what are the chances that it will lead towards Bahubali the conclusion? So one thing that I missed out, which I was talking about. So if you all remember, if two events are completely independent, the probability of them being completely independent, then product of them will be equal to union of them. So in case if my lift is 1, that means both of these events are completely independent, that both of them are equal. That means these events are completely independent and they don't have any relation. If my lift is greater than 1, then they have a relation in between them. And if my lift is less than 1, then there is a negative relation between them. So here is one of my example to understand what is support, confidence and lift. So my support would be, so number of transaction involving both Bahubali the beginning and Bahubali the conclusion by total number of transaction. Confidence would be my total number of transaction where Bahubali the conclusion was bought when Bahubali the beginning was bought. So both at the same time, and by the number of transaction where Bahubali the beginning was bought. So given the condition that my first part is bought, what are the chances that I will go for the second part as well? And left, as I said, the ratio of observed support to the expected support. So for having a good lift, for a few of the cases, I have taken a lift to be greater than 5 as a good scenario to indicate that I have a good relation between these two products. So one more example to understand here, that I have certain number of males and females who play cricket and not, and I need to understand that what would be left in this case. So here I have a probability of a person playing cricket. So let's say my total number of uh, people who play cricket are 3,750 out of 5,000. So my total number of probability, overall probability of playing cricket would be this. Now probability of a person playing cricket, given that the person is female, so there comes my condition part that it has to be a female. So I will only look for the female part on this out of 2000, that becomes my 0.875. And now lift comes into picture, that female plus playing cricket. So now I will divide this, and there comes that my lift is greater than 1. So a positive relation that I can say. And there is some likelihood that if a person is female, then chances are quite higher here. Now, similarly, if I go for male, then I get a contrary result and see that my lift is less than 1. So there is a negative relation here. So this was all about understanding the lift and understanding the scenarios of three parameters that we have in association rules. So now we will move towards the case study. So any questions still here? We are good to go. Fine then. So we will take two case studies for today that we have, and we will try to understand. So here I have my last FM. So this is an online FM station. So let us view this data set and try to understand what is there. So here I have a user who is listening to a particular artist. What is the gender of the user and which country it belongs to? So based on this, I need to understand that what is the likelihood for a person to listen to a particular track after he has listened to a previous track. So what could be my recommendation engine likely to suggest? So I think the data set is quite clear. It is quite easy to comprehend and understand. So this was all about the data set that we have. So let us work on this. So first 19 observations looks good. So after user 1, I have user 3. So I will take care of this. So let's see how many records that we have. So these are quite high number of records. So as I said earlier, this works good in large number of data set, uh, big data set, not for small one. So ideally, number of data that I have is good, and I can start from here. So I am changing my user to factor here. So as I know that it is unique and it has to be on a certain level, so I'm changing it to factor. So levels would be quite high. So it has reached the almost limit and it cannot print beyond this. And levels of artists that I have is also quite high. So I only want to extract the unique ones and try to figure out that how it will work. So here is a library for or the package for association rule, A rules. So all the work that we need to do with association rule are there in this package and we will be using this. And this is the most widely used package for association rules. So here one thing that I'm splitting it on the basis of artist and the user. So one I will have the user and second is how many artists that it they have listened to. So let me show you that how it works. So here I have. So first when you look at the data set, it was 111. First user has listened to so many artists. Where it is labeled. Okay. So let me explain this. So here as you can see, for first user there were so many artists and uh, so this was actually along the columns and now I want to put it like this. So first user has listened to these artists. Then my second user, so after one comes number three. So these are the artists that it has listened to. So now my data is in perfect shape that I want. And now let us work with this. Now here, I want to keep only the unique artists, not the uh, duplicate one, so that there is no repetition. And also, it becomes quite easier to deal with the data because when there are a lot of repetition and duplicates, then the problem is, as you have seen, that the number of data that we have or the number of observation is quite high, and it will be difficult to deal with it. So that will be a challenge for us, and that is why keeping unit would help. So now here if I see, I have got item frequency for all the artists that it has here. So let us understand this in this way. So this is mainly the item frequency that I have. So among all the artists that I have, or you can say the uh, yeah, the artist or the people or the group of people that you are listening to. So this belongs to Radiohead, the Beatles, Coldplay, and so on. So and all of them I have arranged in a descending order. So from top to in the descending order. So now let us set some parameter and do this a priori or this association rule. Implement this. So here I've kept the threshold less support 0.01 and confidence zero point 0.5, and let us try to build on this basis. So here I have got quite a lot number of around 50s that I have got, and for each of them, if you see, so left hand side is my TI. So in case if TI is there, then what are the chances to have my Kanye West, Pussycat Dolls with Rihanna? And here I have listed my support and confidence. And if I check my third column, it is my lift. And how many counts is supporting this? So a lift of 8, 13, 3, 8, these are quite good number. Anything above 5 should be considered as worth and should be taken for analysis. So let us filter out lift by 5 and try to see that how many things that we get. So here we have only 6 of these, and with top lift that we have, so 13. So here we have the maximum lift. So maximum suggestion would be for the Pussycat Doll to Rihanna. And let us sort this with the level of confidence and then see. There we have maximum confidence and down. So this is what we have obtained from the dataset that we had. That given that the person has listened to so and so artist, that what could be the recommendation that we can make? Okay, so first data set was all about working with association of artists that we have, and now we have a second data set here which talks about predicting the income or the class of income that we have. So here again, let us go through the data set and try to understand what this data is all about and how we can understand this better. So here you can see uh, I have age of an employee, working class, and this is some FNG weight or something like that. Education, education number, marital status, occupation, relationship, race, gender, then capital gain, capital loss, and so on and so forth. And this is my final variable, that income. So based on this association rule, that if there is an association between these factors, will I be able to predict that what would be the class of income? So let us try to work with this and try to understand if this can be done. So let us see how much data that we have here. So it is quite large number of data, 48,000 with 15 variables. Good enough to work with. We have just seen the data, so just a glimpse of it. Of first 3 rows, 3 observations, and this is how it has been distributed. So now let us make some adjustment in the data set and try to understand. And because it is an association rule, we will try to work with only categorical variables And if it is not, we will try to convert it into a categorical variable and then try to work. So age, what I'm doing is I'm taking from 15 to 25, 45, 65, and then 100, and I'm uh, classifying it in this level: young, middle age, senior, and old. So let me run this code. And now hours per week. So how many hours per week the person works? On basis of these numbers, I am classifying it as part-time, full-time, overtime, or workaholic. And again, capital gain also something like this I'm working, like none, low, and high. Capital loss also none, low, and high. And second is transaction. So what we did in the previous data set as well, to understand that it is a transaction and it has to deal in that fashion. So now if I look at my data set, so it will be a bit different. That it has been set like this. So as dot matrix, what it does, it actually creates all the dummy variables for my data. So in categorical variables, what happens is a particular column will have uh, certain levels in that column. So like I have mentioned it earlier that capital loss is none, high, none, low, high. Capital gain is none, low, high. Now I will transform it into a particular column so that it marks as an indicator for me. And this work is done with as matrix. Now if you see there, I have many columns here. So and it has mentioned as true and false. So what it has does it has transformed my rows into columns, and it has labeled it as true and false. And now if I check my dimension, 15 columns have transformed into 115. So number of rows remaining same, but my columns have increased. Okay, so now let us try to work on this and see that item frequency, what we can see here. So among all of them, capital loss is none, so highest frequency occurring here of true, then capital gain, and so on and so forth. So if I maximize it and try to show you, so this is what it is. So most of the time it has occurred like capital loss is none. So maximum occurrence or the column for which there has been maximum occurrence as true. Sex is equal to male, so it will be either one of two. So it ideally it should have been at the 50% mark, but it is on a bit higher side. So income small and so on and so forth. So this is without any working. So just on the raw data set, and let us now apply that rule of a priori or association rule. And with I have set my parameters as support at 0.01 and confidence at zero point 0.6. And let us now try to work with this and try to understand that how my results would be. So let us try to inspect that what are the results that we have got if we filter out for lift 1.2 and greater and try to understand that what are all the things that we have got. So here if you can see, so this is my left hand side and this is my right hand side. So for a particular scenarios, so here I filtered out only for income equal to small in right hand side. So in right hand side only has income in small and lift greater than 1.5, and I'm only analyzing for income small, and let us try to explore that what it has made. So work as private class, marital status, never married, then it has some small income. So see, and when this kind of association occurs, then what my right hand side becomes is small income. Again, when this kind of association occurs, result is my small income, and so on. And also keeping anything close to one in the left doesn't make much of a sense. So considering this is a good way to so here in the inspect, if I make it 10 and then try to see. So here also I have got quite a good number of association, and these rules will actually help me to make a certain classification. So age equal to young, work class private, marital status never married, relationship own child, sex male, capital gain none, and works part time. So small income. So in a way working good. So let us try to see only for the large income with the same lift, and let us try to explore that what would be my results. So here also I'm setting it for first 10 observations and try to see that what will be my results. So here also if you see that capital gain high, one of the key determining factor for large income, it has come into picture, and people with a larger income are supposed to be married. They are not young that they won't have any that they will be never married. So again capital gain high, this is none, income is large. Race is also a determining factor at some stages, and here you can see lift is quite high than what we got here previously for small income here in these cases. So this is a kind of analysis that we have done here. So this was all about the case studies that I had for today and all the material and understanding of the concepts. So that's all from my side. Thanks everyone for attending this session. Have a nice Saturday. So we will meet tomorrow for our next session, and this will be the last session for this course.